Okay, it's top of the hour. I guess we'll give it a few more minutes for people to trickle in, but I guess still, if people should probably start doing the question if anybody would like to volunteer to take notes. No need to be terribly, detailed. Just action items and decisions is really all we need. And you can use the note-taking tool, which is linked from the web from this conference at the top right.
Do we have a Jabber scribe also?
I'm not positive we need one in this context, but if somebody wants to volunteer for that, that would probably be good too.
On an eye out on Jabber if people need something said.
Great, thank you, James. That was James Gracing. Sorry, I don't know how to pronounce your last name. And yes, you don't have to use the note-taking tool HedgeDoc if you don't want to. If you want to take notes yourself and email them to us, that would be fine too.
Don't volunteer all at once, but
yes.
Yeah, we really do need this. Well, I guess we can start calling on people, eh, Jonathan?
Yeah, I guess so.
Mo, can we call upon your services as a note taker?
Sure, I can take notes.
Thanks, Mo. Okay. Just a few meeting tips. This session is being recorded. You do need a data tracker login, and hopefully that all worked. I know it was problematic earlier in the week. You can join the session Jabber room via the meeting agenda, although I'm not sure why you'd need to. Please use headphones or an echo canceling speakerphone and state your full name before speaking so that we can get it in the notes. You enter the queue with the hand raising tool and leave with it as well. You do need to enable your audio to be heard and unmute yourself. You don't have to enable video if you don't want to. Here's the note well, a reminder of IETF policies. By participating, you agree to follow these policies, which are listed below, BCP 9 through 79. Please read them and understand them. In addition to the IPR policies, we do have a policy on guidelines for conduct, an anti-harassment policy and procedures. If you're having concerns about observed behavior, please talk to the Ombuds team. And we do strive to create an environment in which people are treated with dignity, decency, and respect, and we expect you to behave according to professional standards and demonstrate appropriate workplace behavior. So if you believe you've been harassed or notice that someone else is being harassed or have any other concerns, please talk to the Ombuds persons. Right, as Jonathan mentioned, we have the notes on the note-taking tool at this link. The agenda has been posted, and we have the Jabber scribe and note takers. And this is the agenda. Do we have any additions or subtractions or modifications? Okay, hearing none, we will move on to the draft status. Why don't you want to cover this, Jonathan?
Yeah, I
I guess
think,
the only new thing is RFC 9134 from the publications. Right?
yeah, right. Yeah, I think, yeah. So yeah, JPEG XS has been published, so good work there. Let's see, yeah, VP9 is in the RC editor queue. It's waiting on LRR, which is waiting on frame marking. We did a pub rec on cryptx, so that should go through the ADs soon. Frame marking, as of about an hour ago, this notice incorrect. We needed an updated draft because we decided to change it to experimental. Mo published that this morning, so now I will do the write-up on that, and hopefully that should get done. We dropped Tetra a while ago. You probably dropped this from the draft status too, as of next time. So if anybody's interested in Tetra, let us know. But in the meantime, we can ignore that. And we adopted a few drafts. And I'm blanking on which 17983. I'm blanking on which 17983 is. I'm sorry. Yes.
That's quick multiplexing.
Oh, quick multiplexing. Right. Yes. Yes. So, but I think all our other milestones are going to be discussed here today. So yeah, so VVC is both adopted and in first working group last call. There were a lot of comments there mostly from the VVC community itself. So it's great that they're participating here. And at least Stefan will be talking about that later.
All right. So now we're going to talk briefly, hopefully, about recent liaison statements. We have a request from the W3C Web Transport Working Group, and Jan Ivar is here to talk a little bit about that. And then we have a liaison from ISO IEC JTC1 SC29 Working Group 3 about green metadata. So, Jan Ivar.
All right, can you hear me?
We can.
Hello, yes, I'm Yanni Vadrori from Mozilla. I co-chair the W3C Web Transport Working Group, where one of our use cases is bidirectional real-time audio-video communication over web transport, which is a JavaScript API on top of IETF Web Transport and Quick. And the problem we're having there is when sending video, when a client is sending video to a server, and the problem there is the client does not have enough information to know when it can reapply a multiplicative increase in the media send rate to recover from prior congestion. So basically, we can reduce send rate in the face of congestion, but we don't know how to rapidly reapply a faster send rate afterwards when the congestion goes away. So the request is to know if, so we're glad to hear that this working group is considering RTP over Quick, and we're concerned. We would like to know if RTP over Quick can satisfy this use case, and if so, what measurements could a browser make available to a JS client to assist with this problem, and would it perhaps require some form of selectable, replaceable, even congestion control? And if so, which algorithms? Thank you.
Yeah, I would caution Jan Ivar that RTP over web transport is a little bit different from RTP over Quick. So maybe we'll get into that in the session to follow because it's not as tightly coupled. But so I guess, can you raise some of these issues in the discussion that follows, and we'll try to see where to go from there. Does that make sense?
Okay, will do.
Okay. The second liaison is from ISO IEC JTC1 SC29 Working Group 3. Do we have a representative to talk about this liaison request?
I see. See what cards. See, I hope I'm pronouncing that right in the queue. Are you? So feel free. Go ahead.
Hi, can you hear me? So
Yes, we can.
Yes, I can speak on that. My colleagues worked on this. If it's okay, I can go through.
Please.
So this liaison is from 809 Group 3, Epic Systems, and they would like to point an update on the progress of this standard 23001-11, which is energy efficient media consumption green metadata. This has been, 2015-19 first and second editions, and now it's, the third edition is currently in the committee draft series status. And just as an overview, in general, this standard provides various type of metadata that enable management of there are these four bullets: management of decoder power consumption or display power consumption, and for offline applications or for like adaptive streaming or dash applications, it provides media selection metadata, and also quality recovery for video encoding power consumption. So different kind of metadata are provided in this specification. And recently, the third edition of this standard, which is pointed to in this LS, provides a bunch of new features. For example, these three bullets say here there's now interactive signaling for remote decoder power reduction that gives better power reductions, and also VVC SCI messages for carrying green metadata related to complexity metrics. This has been added, and also VVC SCI messages that can also carry metrics for quality recovery after low power encoding. So a bunch of new features have been added, and Epic hope that this information is of interest to this group, and we can consider using this in this group. These different metadata have all a very different shape and form. Some are for live applications, some are for adaptive streaming applications, and some are forward direction from sender to receiver, some are from receiver side to the sender side. So my imagination is that the metadata that is to be transferred from receiver to the sender side, that's something especially where some container formats and so on might be of interest. Group. That's my take on it. So that was just like a quick 1-minute summary on this LS. And if there are questions, I can try to answer them. I see James.
Reading through this, it looks like you're targeting VVC. Is there any interest in porting this to other, potentially older codecs that are in more use today?
This is the third edition that now adds VVC, but already there are metrics for older codecs available. So yes, they are already in the previous editions.
Okay.
Stefan?
So,
Question would be, have you any real world deployment of these previous editions? I mean, the stuff is around now for a few years, right?
That is where I don't have any complete information. If there's anybody else on this call, I'm also fairly new to this. Okay, maybe we can take it on Reflector and so on, so we can have some discussion.
is there any action required of the AVT core working group other than discussion on the mailing list?
I mean, it seeks some feedback of interest from the group. So yeah.
I mean, I think if insofar it's I guess that's not one of the elements is the receiver to sender feedback. So I think if somebody is interested in submitting a draft on that, I think we would certainly be interested in it, and we can take up if the work group wants to do it. But I think certainly I think any sort of receiver to sender feedback over RTCP is in scope for this group. So if somebody wants to do that work, I think there would be interest in that. I mean, assuming there's interest in it in the community.
That probably should be noted in the minutes.
Mm-hmm.
So I would assume then we can do some email communication on this, on the reflector.
Absolutely.
All right.
Okay, thank you.
Thank you.
Next
Stefan?
topic is RTP over. Yeah.
Hold on. Stefan and Colin are in the queue.
Okay.
So just one remark that if someone were interested in this type of stuff, then of course the forward direction is also something. I mean, a lot of this gets, as far as I understand, a lot of this can get piggybacked into the codec bitstream using SAI messages and such. But it could also be multiplexed by simply creating its own payload format, right? And that way it may be applicable also to non-MPEG standards. So, I mean, see, what I want to say is the chances to work on that are not limited to the return direction. Yeah, there's a lot done in this area. Whether it's worth doing it, that we'll see. Yeah, thank you.
Fair enough. Colin?
Yeah, hi. So I wanted to return back to the first liaison statement, just briefly talking about congestion control. It would seem that the issues of congestion control are coming up in a bunch of different groups. And I know the Media Over Quick side meeting was talking about this, and it's come up in a bunch of different places. And certainly for congestion control for RTP over UDP, I know we had the RMCAT group, which tried to do a bunch of algorithms. And I'm not sure those algorithms directly apply to Quick, so I'm not suggesting we take the work there, but I was wondering if we should maybe have a broader conversation about where we do media congestion control over Quick, and whether that's sort of RTP specific or a more general conversation. So it's maybe something we should bring up with the ADs at some point.
Yeah. Well, I think the presentation to follow, Colin, will directly bear on that question. So maybe we can talk about it during the presentation or in the Q&A.
Sure. I think it's more general than RTP over Quick.
Yeah.
But,
yeah. Anyone else in the queue?
No, that's it. It seems to be it. So let's
Okay.
go on to the first presentation.
All right. So we're now going to hand it over to the RTP over Quick team.
Yeah. Hi. Can you hear me?
Yes.
Cool. Yeah. Thanks for inviting us to present here again today. In July, we already presented the mapping of RTP onto Quick draft. And today we would like to go a bit more into detail on congestion control for RTP over Quick. On the next slide, I'd like to start with a short overview on the context of the draft. There are actually two similar drafts. The other one is from Sam Hurst from BBC Research and Development, and both drafts provide a basic encapsulation for RTP and RTCP over Quick. Both of the drafts use the unreliable datagram extension with a flow identifier to demultiplex different RTP sessions. And our draft focuses a bit more on congestion control and the interface requirements for Quick implementations and congestion controlling. And yeah, both drafts use SDP for signaling.
Harold, did you have a question? Or are you just getting in the queue to talk? Sorry, go ahead, Matt. Harold just wants to do responding.
Okay.
Oh, there he is.
Yeah.
No, I read through the draft and couldn't figure out why he wanted to carry multiple RTP sessions or one Quick session. This might be obvious to someone, but it doesn't seem to be in the draft. And it's a few bytes of tax that I would like to avoid if we don't need it.
Sorry, I'm not sure I understand the question.
He's asking, go ahead.
You put the flow ID into the session. Why do you to demultiplex RTP sessions? Why do you need to demultiplex RTP sessions?
Okay, yeah. That is because in UDP, one would probably typically use different UDP ports and do different RTP sessions over different UDP ports and identify them by that. And in Quick, we can have the RTP sessions in one connection and then try to use all of the information we have available in that one connection to use for different RTP sessions at the same time, like, for example, the congestion control information.
I was trying to figure out the use case where I would want to have multiple RTP sessions and between the same entities, and I couldn't find one. So I was wondering whether it's reasonable to drop this requirement and just say, if you need more RTP sessions, set up more quick connections.
Yeah, maybe I'll take that and we can expand that on the draft and explain it a bit further.
Especially explain the need for it.
Yeah.
Colin?
Yeah, I mean, there was a comment in the chat about not understanding what RTP session meant in this context. I mean, RTP session has a very well-defined meaning in the RTP spec, and we need to make sure that what's meant here is consistent with that meaning, and it's not just being used as an alternative to the SSRC, for example, for demultiplexing users. So I think there's perhaps a deeper conversation about sessions and demultiplexing that should happen at some point.
Okay, then maybe I continue with the presentation on congestion controlling first, and we keep that on a later discussion. Yeah, so today we want to focus on the congestion controlling, and we identified a couple of questions which come up when we do RTP over Quick. And first is that we have congestion control in Quick and RTP. And Quick suggests to use an algorithm similar to Neureno. It does not mandate any congestion control algorithm, and it rather provides a set of connection statistics that can be used by any congestion controller, and other algorithms than Neureno are currently under investigation. And RTP also provides its own congestion control using explicit congestion control signaling in RTCP. For example, there's RFC8888, which provides a feedback format that can be used for algorithms, for example, for algorithms like Scream and NADA, and also GCC as proposed by the RMCAT group. Now, the two main questions we try to investigate in our experimentations are, first, how can we do congestion control for real-time media on top of Quick, which already has its own congestion control on another level? And then the second is if we can reduce RTCP overhead due to duplicate signaling of congestion signaling in Quick and RTCP. Next slide, please. So we did experiments with a couple of different options we could use for congestion control. The first one is that we tried to leave congestion control entirely to Quick and only do some trivial rate adaptation in our media application. We will leave that out today because it's we already know that it's probably better to have a congestion control algorithm which is specified for real time, and we would rather look at these today. The next option is that we disabled Quick's internal congestion control, and we only use the real-time congestion controller like we would use, for example, over UDP, like the algorithms from RMCAT. In our experiments, we use Scream because this existing implementation for Scream was quite easy to integrate in our setup. And then in the last combination, we used Scream and New Reno together. And on the next slide, I have a couple of notes on how to reduce RTCP feedback. We would like to use the quick connection stats which are already available in the transport protocol to reduce the RTCP overhead. And in Quick, we have the datagram draft, which allows an implementation to expose the datagram acknowledgements to the application. And we're using this to identify which RTP packets have arrived at the receiver. We keep track of the sent RTP packets and in which datagrams they were sent and at what time they were sent. So we have the timestamp, and as soon as an acknowledgement arrives, we know that this RTP packet has been received. And then we also use the RTT samples provided by the quick connection statistics to infer a receive timestamp at which the packet arrived at the receiver by just adding half of the RTT, the last known RTT, to the send timestamp we kept track of earlier. On the next slide, I have a short overview of our test implementation. We integrated Quick Go with GStreamer and the Scream implementation. The application transmit video data in RTP packets from one sender to a receiver, using GStreamer to encode and packetize RTP packets, which are then prepended with the flow identifier we talked about earlier and sent to the receiver. The receiver takes the RTP packet and it identifies the RTP session and forwards the data from the packet to the corresponding GStreamer pipeline. And then we use a slightly modified version of Quick Go to be able to selectively disable New Reno in our experiments and also to expose the connection statistics and the datagram acknowledgements. We build a test bed setup on the next slide, please.
Yes, I had a question about the timestamp feedback. From what I understand, the purpose of that in RTCP is for congestion controls to understand the one-way delay, to understand variance in one-way delay, and those delay-sensitive algorithms can use that high-fidelity one-way delay inferencing from that. But if you're trying to synthesize that using round-trip times, it seems like you've lost the one-way delay aspect of that, which may be important for some of those congestion control algorithms.
Yeah, I think we will get back to that in a later slide on the results for this inferring. And okay. There are drafts, or quite recent drafts, which also try to use the receive timestamps directly in acknowledgements. I will reference that later. Yeah, next slide, please. So we have a test bed setup in which we run both of the applications in separate containers on the same host. And we use the virtual network interfaces in the containers to simulate different network conditions. We configured a bandwidth limit of 1 megabit per second, and we run the experiments with different one-way delays. And after 60 seconds of a video run, of a video transmission, we reduce the available link capacity to 500 kilobit per second to see how the algorithms and the transport react to this. And then our application logs incoming and outgoing RTP and RTCP packets for analysis afterwards. And we also calculate PSNR and SM statistics on the raw video files. Next slide, please. So the first results for Scream using RTP over Quick using Scream and comparing this to UDP. The left graph shows the Quick implementation and the right one UDP. And we can see that the results are quite similar, so it seems to be possible to use quick datagrams to transmit RTP. And we can also see that the target bitrate of the screen congestion control are slightly below the one in UDP. We're not exactly sure why yet, maybe due to some overhead, but we need to investigate that further. On the next slide.
So hold on. The screen plus quick is just the quick congestion control replaced by screen, right?
Yes.
Okay.
Then on the next slide, we leave the quick congestion controller enabled, and we congestion control the real-time traffic by screen before we put it to quick. So everything goes through both congestion controllers, and we see that in the first part of the video transmission, it seems to behave very similar to the previous slide, but that probably is due to application limited transmission. So as long as screen is sending less data than Ureno would, then we are in this application limited state where Ureno doesn't really do much yet. But as soon as then the link capacity is reduced to 500 kilobit per second for 30 seconds, we see that both congestion controllers try to adapt to the new link capacity, and the screen target bitrate drops to almost 0, and the ramp up also does not happen at all in the case of a 1 millisecond delay. It may be that happens much later if we looked into it for a longer time, but this is already not really usable, so we didn't investigate that further. And in the second case of a one-way delay with 50 milliseconds, it seems to be ramping up, but also only much later after the target bitrate already dropped to 0 earlier. Then on the next slide, we show some results for trying to reduce RTCP overhead. On the left side, we see the results with RTP over quick using RTCP feedback, and on the right side, RTP over quick using only the inferred feedback I described earlier. We can see that the top two experiments looks pretty similar, so it seems to be possible in general to use the quick statistics for RTCP feedback, but we also see that in the later experiments, especially in the one with 150 milliseconds one-way delay, the ramp up in the beginning works much slower or starts much slower. And in our experiments, we generate the feedback at a fixed interval, and we think that the instability in the last experiments are due to this fixed generation of feedback, which may lead to some acknowledgements from quick arriving after we generate the next feedback, even though the RTP packet has already been received by the receiver. And due to delayed and aggregated AGs, they only arrive a little bit too late at our sender, so that some feedback is not included, which leads to feedback which would be less precise than the one RTCP could provide. There are probably 2 drafts which could improve the situation, because there's one draft for quick timestamps, which would give us timestamps for which would help us to estimate the one-way delay, as we already talked about earlier. And then there's a very recent draft which gives timestamps for received packets, and that would also help to improve the generated feedback, because we then wouldn't have to use the latest RTT samples anymore, and instead we could just use the feedback which is directly on what we need from quick, instead of inferring it from the feedback which is already present in quick now. Then we have one more slide on prioritization. We ran all the experiments again with the second stream opened in quick, this time not datagrams, but the real quick stream, which sends constant data. And in this case, we see that the application probably needs some prioritization between real-time data in quick datagrams and background traffic within the same connection, as in our experiment we see that the target bit rate quickly degrades, and it might even starve because of the background data. And yeah, there's then probably some better scheduling or prioritization necessary. But this is also a very artificial setup in our experiments, because we really send a lot of background data, and there are probably better experiments needed with more natural forms of background traffic, like on-off HTTP requests or something like that, instead of constant sending data. Yep, then on the last slide, I come to the conclusion. I think there are mainly three results we have here. So the first one is that it's probably problematic to run two separate congestion control loops at the same time, like a real-time congestion control algorithm like Screen for the real-time data, and something like Neureno and Quick at the same time for all of the outgoing data on the connection. And the second is that it's probably possible to use quick state information to reduce RTCP feedback, but that could probably also profit from some optimizations which would be provided by the received timestamp draft, or something similar, which would give more detailed information than just the RTT, and using this RTT for the feedback info. And then the last point is that some prioritization is necessary, as we've seen on the last slide. Yeah, in the future, we plan to do some more experiments on different congestion control algorithms and different forms of competing traffic and different network topologies. And we would also like to try to find some way to do better prioritization than no prioritization at all, to see how we can use one quick connection for real-time data and non-real-time data at the same time. Yeah,
I see
thanks so far.
Justin in the queue.
Hey, can you hear me?
Yep.
Yeah.
Okay. Yeah, this is really good work. I'm glad to see this kind of moving forward. I guess I have 3 points here that I think would be good for us to try to limit scope here. One would be, is there anything besides received timestamps that we would need to have the same information that RTP or what you had here as UDP would have? Because I think if we get there, then we can feel pretty confident that we have everything at a protocol level to do good for real-time congestion control. Second thing is that, I think trying to prioritize real-time and non-real-time right now might be putting off a lot. And we might just say open a different quick connection for non-real-time stuff, because that's how it works today. And not to say that that's where we stop, but that might be a good milestone of saying that we just basically replace the entire congestion controller if we do RTP flows today and get that working over quick. And I think that would be a pretty good accomplishment. And then last, one thing we haven't really talked about here is sort of overhead of how many more bytes are we putting on the wire for each RTP packet, and where are we sending redundant RTP feedback. And it would be good to sort of dive into that and see, what those numbers are, and then we start thinking about, is there anything that can be done to mitigate that?
Yeah, I think I agree with all of the points you said. Yeah.
Sergio? Sergio, I don't hear you. Sergio, see if you can figure out your audio in the meantime, Suhas. I'm not hearing Suhas either.
Can you hear me?
Yeah, now I hear
Jonathan?
you. Yes, I do.
Okay, so I just wanted to echo on some point and make an observation on what Justin made, and also a clarification question is to the presenter was there any specific reason why RTP was considered for this investigation? Is that was the reason because some sense of interoperability with existing RTP stacks, or was that a protocol of choice to pick? I just want to understand the context behind that.
Can you hear me now?
Yes.
Okay, stupid. So I had the headset muted even I spoke. Okay, so
I think I'd like to let Mathis respond to Suhas first.
yeah.
Sorry, I'm not sure I understand the question. It was a bit hard to understand. I'm sorry.
Yeah, that first is that's I think that this is our own work, and if you have the code there to replicate the results, and maybe it is on our own.
Yeah, we have the code. It is on GitHub, but it's not probably good documented right now. But we plan to do that soon.
Yeah, I was also interested in how to replicate the network adaptation and things like that. So because the code is typically available, but the how to replicate the actual test could be interesting as well.
Yeah, we can share that definitely.
Okay, and the second thing is that I think that one thing that it is also related to the web transport thing is that this kind of test seems to be very focused on what a native application can do by modifying or integrating deeply with the quick stack, or providing but if we are using web transport, I think that we have to consider also what will happen if the bandwidth estimation is going to be run in JavaScript, because probably the browser will not provide a de facto bandwidth estimation for the application level. How can we make this work when the application that it is using the quick stack is untrusted? For example, we are going to replace the RTCP feedback from this quick feedback, how this will be exposed to the application, because I think that they will impact quite a lot in what we will be able to do with transport.
Yeah, I think this is very much focused on our native application right now, which we built for testing, and there will probably be a need for more broader discussion on API things in the future.
Yeah, because for example, I doubt that we can just disable the quick congestion control and let the application running on JavaScript just behave properly. So we will have to find a way of trying to have both working simultaneously. Even I think that it was sometime proposed that have some circuit breakers in case the bandwidth estimation done by the application is not behaving properly or things like that. But anyway, I think that it is a very great work that you have done so far, and just hope to be able to improve it.
Thanks.
I guess Bernard, you're next up. As soon as an individual in the queue.
I guess I had wanted to focus on some of the questions Jan Ivar asked, which is, I guess your paper has the different metrics that you've been using, and I guess most of those are probably exposable in web transport, including the timestamp info. I guess the one thing that wouldn't potentially be exposable is the detailed ACK data, because in a browser, basically you can't assume that the ACKs reflect the application, what it got, but maybe the timestamp and other info from the ACKs could be provided up. I guess yeah, and originally in Web Transport we did have the concept of adding a congestion control selector to the constructor, and I guess to Justin's point, that would be on a quick connection level. So I guess one thing to think about would be if you had separate quick connections instead of the prioritization thing, operating with different congestion control algorithms, what the behavior might be there. And also web transport does have prioritization built in, but it's probably of the kind that your research shows is going to be problematic, which is basically right now the datagrams get absolute priority. So they will starve out the reliable streams.
Yeah, I think we could do more experiments on that in web transport, especially on the prioritization. And yeah, I agree that it might be hard to expose all of the data we use in our experiments yet. Yeah.
Okay, thank you.
Spencer?
Just wanted to thank you for bringing this work forward, and thanks to the chairs for bringing this forward in AVTCORE. The question I probably or the suggestion I have is this draft did not actually flag AVTCORE in the file name, and I've been having some conversations on the Media Over Quick mailing list, which is only a mailing list, about another draft that's relevant here that doesn't have AVTCORE in the name. It was focused on the SVP for RTP over Quick, but recognizing that was going to have a lot of was going to have to reflect a lot of discussions about what RTP over Quick was actually going to look like. Are we, for the chairs, are we to the point where we should be putting AVTCORE in the draft names to get more visibility within the group here?
I mean, I don't know is the short answer. I mean, because we don't know if this is ultimately going to end up in AVTCORE. I mean, visibility is always good.
I understand that. Yeah, I'm thinking mostly from the standpoint of making sure the right people are looking at it.
And
you all can think about that and let us know.
Yeah, sure.
The discussions we've been having for my draft in this space and in the mock mailing list are, I think they're definitely ready to move into AVTCORE or a group like that rather than kind of an ad hoc overall Media Over Quick discussion.
Yeah, I mean, insofar as things are, RTP-ish, feel free to target them at AVTCORE. It's, cool. It doesn't hurt anything if we're wrong.
Thank you so much.
Yeah. Bernard? Bernard's out of the queue. Colin?
Yeah, hi. So, I mean, there's a bunch of discussion in the chat about sort of short-term and long-term approaches, and I think that's important. I think we should make sure we have that broader sort of architectural conversation about where we want to go, rather than necessarily just sleepwalking into reusing RTP here. The actual reason I got up to the mic was the comments about using separate connections to avoid having the congestion control prioritization discussion. I mean, separate connections causes quite a lot of pain in the current model, and we should have a deliberate discussion about whether we think that's acceptable pain, or whether we want to make a conscious effort to reduce that and try to make everything run over a single connection, even if it means more congestion control and prioritization work.
Okay, James?
Thank you. Thank you for doing this work. The question that I have is, you've only looked at doing this in the unidirectional flow, right? This is just a one sender, one receiver, one flow of media, correct?
Yes, true.
Cool.
In our experimentations, it is probably possible to build something else with the draft, but that's what we experimented with. Yeah.
Cool. I think that when we, sort of tagging on from Colin's last remark around connections and just various thoughts around how multiplexing might be dealt with in this space, bidirectional flows of media should also be considered as well. We've had an awful lot of discussions earlier this week in the media, the MOQ side meeting and in other sort of forums around those use cases. And I think that there may be, and this is a hand wave, potential issues when it comes to conflicts, competition between congestion control, depending on which way we tackle the connectivity and multiplexing of the sessions.
Yeah, that's probably true. We were planning to, or our current test setup is kind of inspired by the test cases evaluation for congestion control from RMCAT, but they don't completely implement all of it. And yeah, as I said, we would like to do more experimentations with that, and we should probably also include bidirectional streams there.
Justin?
So I just want to sort of add on to Colin's point, where he sort of mentioned that, well, maybe we should take on, prioritization. I think that for any specific work in this area, we probably want to have a good sense of what our goals are. What would count as good enough? What would count as like a reasonable V1? What things do we think we have to do? I think as authors have shown, you can get some results even just now, just by sort of encapsulating RTP within quick datagrams. But what would be necessary for us to kind of consider this something that we want to deploy on, whether it's overhead, whether it's packet rate optimization. This is still an early draft, so this is fine where it is right now. But as this moves forward, I think kind of lining up as a working group, what do we think that they should be trying to solve? I think would help us all kind of get to a shared picture of where we want to end up.
Yep, fully agree with all of that.
Okay, and we're kind of over time, but this is an area with a lot of interest, so I figured we would let us go over. But thank you all, and I guess discussion probably on the APT list or the mock list or both. Probably, if you're interested in this, you should be subscribed to both, but hopefully we can try to converge on where we're having the discussion. And yes, and to the authors, please continue your experiments. It's very helpful. Sergio?
Yep. Thanks. The cryptex status. So next slide, please. Yeah, we have. Yep.
Hold on one second. Spencer, are you trying to do something with slides or no? You're okay. Okay, go ahead, Sergio.
Yeah, we have released.
Hold on, Spencer. Spencer, are you trying to say something? No. Okay. I don't know what Spencer's saying. Okay. Sorry.
Okay, so we have been put a new draft for cryptex that it is does two clarification. One was the authentication after encryption, and also how what's the meaning of the cryptex attribute when it is present with bundle. It does not change anything on the draft. It's just clarifications that were needed because it was not clear at the moment. Regarding the implementation status, we still have only two implementations currently. One is done by you, Jonathan, that in DC, and the pull request that I have for Live SRTP, that it is not yet merged, but I hope that it will be soon. And we have it has been requested for publication, and we are already also trying to have an issue open for adding the API for enable and disable it in WebRTC. So I think that's all, and I think that there is nothing for the review, but we will just need to do the review. But I think that there is nothing pending to be done in the current draft.
Is there one more slide? Yeah. Okay.
So,
all right. Yes, I think that's in good shape, and it's in the hands of our AD now. So hopefully that will get moving on quickly. And Stefan, are you presenting? Yes.
Yeah, hi. No, this is the two payload formats for VVC and EVC. Will be a quick thing. Next slide, please. Thank you. So we had a working group last call a few weeks ago, a few months ago actually, and we got comments from Bernard, from Miska, and from Henry, and they were all in all the activity on the mailing list in response to this working group last call was quite active. We had more than 30 emails there, and the comments were also quite extensive. And but over the time, I think we got to a good understanding of what the commenters were asking, and I think we addressed most of them in this version number 12, which was posted just before the deadline. And we have a revision number 13 in the works that is currently reviewed by the authors, where Miska actually put in some additional text related to the remaining issue somewhere deep down in the offer answer. And that's, I mean, I can promise it for pretty quickly. What's a little bit concerning to me is that our usual suspects here on this in this working group didn't comment at all, yeah, except Bernard. And I would guess that that's perhaps because all these payload formats for null unit based codecs are so similar nowadays that perhaps most of the bugs have been ironed out much earlier. But really, if it would be good if people could take one more look at it at some point. Now, I think the real test will come when this thing goes out to publication request and all these security guys come out of the woods and talk about the newest trend that they want to see in the security sections, and similar maybe the congestion control guys. I don't know. So yeah, and well, so what we will be doing is we'll publish one more revision of the VVC draft pretty soon. I gave you a target date mid of the month, but we will do that earlier, I think, probably as soon as later today. And then we suggest that maybe another working group last call is adequate, since the text changes are not insubstantial. Although they are deep down in the details where the VVC codec maps to the offer answer mostly. And then I think we're ready for, after that working group last call, for publication request. Next slide, please. Thanks, Bernard. Now, this was an issue that's more a generic question that was triggered by a comment from Bernard, where he said there are no complete examples of the SDP offer answer negotiation in the draft. That was in the context, I think, mostly of the scalability related, rather complex offer answer scenarios that this draft would allow. And that raises a little bit the philosophical question of what good do examples do? Yeah, so one thing that I've seen rather consistently in implementations by people who are not, say, regular participants of this group is that they take code snippets from the drafts, or at least, the examples verbatim from the drafts, hack a little bit around them for the special needs they may have, and think that they have something that ought to work with other people's implementation. And typically it does not. Very often it does not. And the reason for that is, I think, that people simply take the examples as shortcuts for for the way how things ought to be done, and don't really get a full understanding of what's going on. We had this discussion before a few years ago, or a decade ago or so, and for the HEVC payload format. There we later on decided not to go for full examples, and I just want to kind of reconfirm that that's the right thing to do. I mean, we can add more examples if we absolutely need to, but for the reasons I stated, it's not laziness. It's really, it's more, I think examples teach away too much from the complexity of the problems that are hidden in those of our answer cap exchange options that we have in those drafts. So I asked this question on the mailing list. There was no response. What do people think?
Bernard is with you.
Yeah, thanks, Stefan. I guess what I was responding to in part is some of the issues we've seen with implementations and figuring out what they do. There's a pretty widespread problem now with people inventing their own very different implementations of HEVC, for example. I had an instance where it was integrated with WebRTC and nobody could figure out what it was doing. And I know that's not the fault of the draft because it probably didn't also implement the payload format either. But yeah, it just, I understand your point that, but translating these things into actual implementations it has been problematic because people pick and choose things, and you never know what they're going to do until you actually look at it.
I completely agree. I think the disagreement, if there is any, I don't know, the disagreement is what the cure to this problem is. And
right.
I think the cure is not to put oversimplified examples in a draft that will be copy pasted that may be known as correct, but may not be known as applicable for the particular problem that people have, and that people go away from, frankly, from specs for something as comparatively simple as a payload format. When you compare it to the video codec, that's people take shortcuts. They do it all the time, right? So
yeah.
Unfortunately, I'm not running a standards police. Otherwise, I could do something about it, but I don't. Yeah. So, okay, let me put this as a proposal, or let me put that not as a question, but as a statement. So, unless people speak up pretty darn soon, right now, that they want to see more detailed examples, we're not going to add more examples, and we will be referring to this discussion if we come out of the woods later for more examples.
Mo?
Yeah, I don't think you need examples to spoon feed people. I don't think that's necessary. But in your view, do you think that the current examples give the high order bit of what the most important parts of the draft are trying to convey in their STP, I think that's the useful part, because there's usually a lot of text, and it's usually drafts that have many parameters and many rules on all the parameters. It's hard to lose. It's easy to lose high order bit of functional negotiation in all of the different nuances of the parameters. So do you feel like you've captured just the high order bits and not all the full complete negotiation
So
case?
I think we're good enough if you take this and a little bit of, say, common understanding of how our answer is supposed to work. We are good for the relatively simple use cases, say no scalability.
Right.
Once complex stuff comes into the picture, people have to dig in. People have to understand that, because if you just try to recreate a scalability model without understanding the VVC scalability mechanism, which are not that easy to grok, right? And that 5% of additional complexity that's being added by the payload format. If you don't have a good picture of that and just naively starts implementing, then you will arrive at something that just doesn't work. So but for the relatively simple use cases, if you're using say no scalability or temporal scalability only, you should be fine.
Then I think it's appropriate to not include detailed examples of all the possible subtleties. Implementers should know those subtleties and know the STP for them.
Okay. Good, thanks. I think that's all I had on the VVC thing, so that's on track. Next slide, please. So jumping over to EVC, that's a really short one. Next slide. We haven't refed the 01 working group draft. This tradition of keep alive drafts, I consider, this is just not a good thing. So unless you chairs tell me that we should run keep alive drafts for bookkeeping purposes or something like that, we're not going to do it. However, the draft is still on our internal agenda, and we are committed to deal with that. However, the way we want to do that, and that was, I think, agreed in last summer, is we'll deal with it once we have learned the lessons, and that's especially the lessons I'm expecting on the security side during the IETF last call. So in other words, what we suggest to do is we will produce version 2 after we got the VVC draft through the last call, and then we'll be ready very, very quickly with working group last call of the EVC draft. The alternative would be keep alive if you choose. If that's your preference.
that sounds reasonable to me. I think.
Which one?
Sorry, the no keep alive needed. Sorry.
Wonderful.
Just
okay.
Yeah.
That's basically all.
The other question I had is so when you're saying security, do you think there'll be sufficient, specific security issues that might come up due to something about VVC, or is it just? Okay.
No. If there were specific security issues that I think that would come up, we would have proactively addressed them. No. Okay. This is just doing payload formats for the last 20 years. Something always comes up from that crowd. So I mean, I would be very pleasantly surprised if this time nothing comes up, but something always comes up. So and there's always a need to add a sentence or to the security consideration question. And frankly, in the past, that was also the truth for the congestion control. I think this time congestion control is probably not the big issue anymore because those people are watching video payload formats generally nowadays. But on the security side, it's just, I'm just expecting it without knowing what it may be.
Okay.
Okay, thank you very much.
Okay. I see Mike Fowler in the you. Daniel or Mike, which are you presenting?
Hansen with General Dynamics. I was going to have Mike do our presentation for us.
Okay, go ahead.
Regarding project, and I'll be certainly be here for questions as we go along.
Sounds good. Go ahead.
Hello, can you hear me?
Yes.
Okay. I've been listening to the conversations of the others, and I'll augment the presentation based on some of what I've heard. But as far as I know, the organization we are supporting is new, or somewhat new to the IETF. So I provided a couple slides that discuss our background for the draft RFC that was submitted. The particular protocol we support is called SCIP, Secure Communications Interoperability Protocol. It began in 1994. I was around for the birth of that as a combined Department of Defense and vendor working group. The working group was called the Interoperability Control Working Group. While the SCIP protocol began in 1994, there were predecessors to it. We go back to the PSTN days of early communications that the DoD would do over PSTNs, and then into ISDN, and migrated into IP. All handled with a community of interest, if you want to call it that. And the community was mostly confined in the US for a large part of this. But the goal of this group was to develop the next generation interoperability security protocols supporting the US government and the military interests. Later, around 2001, to include NATO and NATO partners, and the name changed to the SCIP Working Group. The SCIP Working Group is a functional standards making test community that meets 1 or 2 times a year, depending upon the needs. We have separate action items to do. We have demonstrations to provide. We are a functioning body that's been around for a while. Next slide. One of the problems that's come up is about the SCIP information access and awareness. The SCIP standards are currently available to participating government military communities and select OEMs of network equipment and call management servers that support SCIP. Government business entities must request access to relevant information, and access to SCIP standards is based upon a need to know. Now, devices that implement SCIP standards transparently operate over digital carriers. SCIP is an application layer protocol. It doesn't function down in the network layer. The devices, most commercial network and security community personnel are not aware of SCIP, and this can result in the SCIP submedia type SCIP being removed from the SDP of a standard SIP message. So the lack of awareness among the network and security community has become a larger issue as the use of SCIP grows over more commercial carriers, and as network security devices become more restrictive of unknown media. As a side story to that, my first exposure to network security was way back in the early Cisco days of building a firewall based on IP addresses. I think we can all agree it's progressed a lot since then as to what the security appliances do to your network. So we have come across issues. Next slide, please. We have come across issues where the SDP doesn't contain the transport that we need. So the draft RFC submitted to IETF is designed to provide information to network equipment OEMs, network administrators, security personnel, and to help SCIP succeed over the commercial networks. Because SCIP relies on commercial equipment within the network infrastructure to operate. And as security policies have changed, devices have changed from being where you go in and decide what you're going to not let into your network. Now they are more like they're going to deny all, and you have to tell them what you want into your network. And when that telling gets all the way down into the contents of the SDP, SCIP can have a problem. So the SCIP RFC enables network equipment manufacturers to provide an equipment configuration that supports SCIP as a media subtype, so that the network administrators, network security personnel can define and implement compatible network policy, which permits the SCIP media subtype to traverse the network. What the SCIP media subtype provides is end-to-end bit integrity, no transcoding on the channel, and treatment as if the data is clear channel data. And there is actually a precedence to this within the RFC standards of RFC 4040, and we referenced that in the draft submitted. RFC 4040, while it is a gateway protocol, it is meant to take IP traffic and an ISDN BRI network 64K UDI channel and build a end-to-end bit integrity network for the users to use whatever they want. So RFC 4040 develops a clear channel. It just happens to transverse, go from IP to ISDN 64K UDI. So SCIP is to be treated like that on a pure IP network. Next slide. There are two submedia types that have been registered with IANA as RTP payload format media types, audio SCIP and video SCIP. This RFC is needed to provide additional information for those media subtypes, where we include the media type description, the payload format RTP header fields, payload format parameters, and the SDP declaration as the mapping to the SDP, and provides mapping examples, what you'll see on the next slide, I believe. Next slide. This is the contents of the SDP declaration to support a SCIP session. I kind of, like Mo's comment of high order bits, this is just simply what will be included in a SIP invite of what would maybe a normal video call with different codecs listed. So the SCIP devices are presently deployed in the US and NATO tactical networks, and many national networks and some commercial networks using that following SDP media and submedia type. We have deployed products and have had for over a decade using these protocols. So the secure session can be used as audio SCIP, video SCIP, or both, and the mapping is shown there. Presently, I think within the global community, my knowledge is that there are probably about 8-9 nations producing products using these protocols. Next slide. So in summary, here's our issues have occurred because OEMs and network equipment, networks administrators and security personnel are unaware of SCIP and SDP contents necessary to establish secure session. That unawareness is partially tied to the fact that the body of community that this serves is one that has an already standing community, already has a standing set of standards in which to operate to do this. So operating in that environment is one that produces the fact that while we're defining the end products, but we don't have any way to let the people in the middle know what we do. So the draft RFC increases the IETF awareness of the SCIP working group and its efforts to achieve international interoperability. Actually, we'd probably welcome some involvement of the IETF community if they choose to participate in our sessions. The purpose of the RFC is to provide global access to information necessary to support SCIP. And a reference to the RFC provides context and a single reference point for the newly defined IANA media subtypes, audio SCIP and video SCIP. So we have to look at our problem as not just being the end products having interoperability, because everyone else who carries traffic is responsible for defining what's on the network, is responsible for building equipment that implements security plans. They need the knowledge to know how to do that. It even goes down as far as the procurement people. If I, as a network designer, want to support this protocol on my network, how do I reference that to a procurement rep so that they can then write a request for quote to vendors saying this is what your product needs to support. So as in the last bullet, the RFC provides information about SCIP and the SCIP working group community to system network architects, network administrators, security personnel, OEMs, risk analysts, procurement personnel necessary for SCIP to be included in the system security lifecycle. So that's pretty much it in a nutshell. I can respond to questions. I'm not hearing anything.
Hit the wrong button. Basically, you said that the actual content of the SCIP is need to know, which is to say some form of classification, right?
It's not it's basically building a channel by which the end devices will negotiate what they're going to do. They're going to negotiate applications. They're going to negotiate security parameters. So its format itself is not as clearly defined as if you were carrying movie traffic or 729 or something like that.
So basically, this is just establishing a channel over, a opaque application channel over the existing RTP sessions. Then you need to integrate this with things that use the IP telephony. That's what you're saying?
Yes.
Okay. Yeah.
And it has been done in some devices. When we've had direct interaction with vendors, we've been able to, especially those that are aware of the type of work we do, they're saying, oh, okay, so this is just kind of the next generation of what was in the previous. In the PSTN world, we'd be talking to telcos about what they need to do on their network, but there is no real telco anymore.
Bernard?
Yeah, so my question is, what can the AVT Core working group do for you? So are you, I guess the document is an informational RFC. Are you looking for it to be working group last called, or what's the ask from us?
Here's where we have to express some ignorance of how the IFC works. So for our purposes, we look at this as the adoption of this draft RFC is not the end of the game. We have much more work to do, because an RFC doesn't mean anyone's going to implement anything into the product. It takes work beyond that, but an available global reference is a big start. I would ask you, Bernard, where would something like this go? Because it is, in the end, it is the standard that's needed for end products to communicate in the way that they were designed. The recognition that their far end product is a compatible one, and then working over a clear channel, establish what each of the users are capable of doing and want to do.
Yeah, so I think we have our area director here, Murray. I don't know, Murray, if you want to comment on that.
Murray, if you're speaking, we don't hear you.
Oh, why am I not muted?
No, now we hear you.
You can hear me now? Okay.
Yes.
I was just reading over the charter, because it's been a while since I've read it, and as long as this is covered in it, which I haven't finished reading it yet, and working group doesn't have any objections to, or the working group supports the idea of bringing it in since it's informational. I don't think this is a problem to take up, but consensus prevails. But
I mean, as an example, we
could the rest of the discussion.
Yeah. as an example, we could work a group, let's call it. It could be published, I guess, through the independent submissions process also. There's a variety of ways to get it through the publication process, which seems to be the goal.
If you're going for informational, there are several options.
Harold?
Well, that can be a discussion we can have offline as to the benefits of one versus the other, because that's also something that I don't know personally. So,
yeah, I think one of the things you're looking for because of the SDP issues is to get the attention of the SDP directorate and some of the people who make these B2B UAs who are torturing you. So that's kind of another consideration, is how to get the most exposure to them.
that is true. In a sense, they are participants in how network equipment is created by the RFCs that they have endorsed, or information that they have to disposal.
Okay, I think the action item, and correct me, Jonathan, would be to bring this discussion to the mailing list as to how to get this published. Does that make sense to you?
That probably makes sense. I do see some people in the queue, but if you keep it quick, we're running it over time.
Good.
Yeah. Harold?
Yeah, I was struck by the similarities of what you want intermediate nodes to do between this and S-frame, actually. In both cases, the main purpose of the SDP negotiation is to tell other entities on the route, please let this through and don't touch it. Is that an accurate description? I think that's an accurate description of what you present the skip, right?
Yes, it is. We've been building products to this since about, I want to say 2004, 2003.
About 2008 for skip for this. So yeah.
There was a lot in the works before it ever became product.
Yep. Thank you for confirming.
Ed?
Right. The question in the beginning of the earlier slides for this, there was a mention about the TSBCIS specification. It's kind of in the same ballpark, if you will. It's similar, but not the same as what we're doing. I was kind of curious how that was, approval for that was processed through the group.
That was a while ago. I'm not sure how many people here now actually remember.
Okay, yeah, because it was
My
you
voice
mentioned in the
going
very
into
beginning
yeah.
of the presentation.
Yeah, it was on the top of the presentation.
List of RFCs that were approved. I guess since the last meeting or whatever.
Oh, that one. Yeah.
So
go ahead.
I would actually suggest talking to the media type reviewers for that. And I know Murray is one, but wasn't one at that time. So it might be something where you need to ask Ned. But I actually got in queue to ask a different question, which is actually on this slide, if I can point to this. From my understanding of your description, in addition to the two media types that you have in there, you do have data streams, which you describe in this slide as clear channel data. Are you anticipating a media type request separate from the video and audio media type requests for some sort of application/skip as well?
No, the reference to the last bullet on that slide is that the data present on the audio or video skip payload type, it will be treated as clear channel data. Don't mess with it. Whatever's there, just let it go, because there's negotiations going on. We need the bit-to-bit end-to-end bit integrity to make the devices work. And trying to look at the traffic channels not going to help you much.
I think you may want to take another pass through the draft and in your description of that, because that's not the same impression I got with a quick look at the draft. So
Okay.
I want to take a look at that. Thanks.
Well, that's why we're here. Comments.
Stefan?
So having just gone through this Chadwick XS thing where, frankly, a perfectly available ISO standard that just costs a little bit of money raised a big uproar, I think we'll all have a hard time to get anything through the standard IETF process where there needs to be a reference in there to a document that's not available to the public. And so far, my suggestion would be to target from the outset to give this to the independent stream or whatever it's called. So basically, not an IETF document, but still an RFC, and therefore something which most network people pay some attention to. Yeah, and then you only have to go through a conflict review in the IETF, and that's I think much easier. Thank you.
Right, and then that sort of goes back also to my comment about the TSVCI spec, is that it also references documents that were only available through the government. So I guess, again, sort of requesting or understanding how that process worked for that particular RFC and its approval. Again, this sort of similar to what we're path, if you will, that we're asking for.
Colin?
Hi. We seem to be going a little bit backwards in terms of the way the IETF handles these sorts of documents. I was very surprised to see that all that the controversy about the spec that Stefan was just talking about, because we've done lots of payload formats which have had various degrees of difficulty in accessing the specifications over the years. So process-wise, I don't see that there should be a problem with this in IETF, and I think the IETF certainly should be able to publish open specifications that describe how to use a closed thing. So I would sort of somewhat disagree with Stefan and say that this should go through the standard IETF process, because the IETF needs to be able to do this sort of document and has in the past. So I would encourage the group to adopt this and take it on as a payload format specification in the usual way, and work with the chairs to work with the area directors to find a way of making sure this is acceptable. And that may just mean that a small number of people are given access to check that the specification makes sense. Because it's accessible to the community which cares, and I think that's what matters.
If I may speak for a minute, that is possible to request permission for this to look at this. It's a skip standard 214.2 referenced in the draft RFC, and really most of the contents of that document that are of any technical significance are in the draft RFC itself. There's not much more than that.
I mean, I think it probably does need someone who understands RTP from this from the IETF to look at the codec specification and look at what's being proposed and say, yeah, this makes sense. But I don't see that it requires it to be made available to the entire community. It requires it to be available to the community who will be implementing it, and someone to look at the spec and say, yeah, that what's being proposed from the RTP point makes sense. And I'm pretty sure we've done this sort of thing before in IETFs.
That's fine.
Murray?
Yeah, just on that point, the IASG recently has, if you look, there's a BCP 97 is under revision for exactly this reason. We had a number of documents come to us that we were not able to evaluate because the specification to which it referred was not available to us. I think the proposal is exactly what I think Colin just said. As long as the reviewers, the people who need to review it and approve it, can get access to it to make sure the wrapping specification is right, then it can go forward. It doesn't need to be, permanently open public. But it is a problem if the reviewers can't do their jobs. That's all.
We just have to. The reviewers will just have to contact there's a contact within the draft RFC at the bottom. Requesting access. If we know in advance who they are, we can make sure that they get approved.
Yeah, I think that's probably workable.
Okay, so do we have the action items identified? Guess we have mailing list discussion.
I'm not sure. Go ahead.
Sorry, my question is along the line of that, the action items. I guess you're suggesting that we make the background document skip 214.2 available to certain people. We would need to know who, and we'll help guide them through the process of who they need to talk to. And who would be, on the IETF side, who would be contacting us, letting us know who needs to get access to the document?
Well, I think that's probably a chair item. Is that right, Jonathan?
It sounds right to me,
yeah. So we will try to get back to you with feedback.
Okay.
And I can think of some folks who might be appropriate, but we'll have to discuss it.
And we'll revisit the draft RFC for making it clear that the last bullet in this slide referencing it as treated as clear channel data is concise and exact enough to specify that it's referencing just the data that is traveling within the audio skip or video skip traffic channels.
Okay. Well, thank you.
Thank you.
Thank you.
Okay, Yuan, go ahead.
Can you hear me? Yeah.
Yes.
Right. Cool. Next slide, please. So yeah, I first wanted to update on the AVTCORE working group on S-frame progress that has been made in various areas. So first, you might already be aware that the IETF S-frame working group issued a call for adoption of the OMAR S-frame draft, which is mostly talking about the format itself and has some architecture points as well. So it was a successful call with some feedback that maybe the draft should be split in a pure format-based spec and a separate architecture draft. In addition to that, on the mailing list or in various places, it was noted that there's interest in using S-frame format either at the packet level or the frame level, but not in between, which might be a good simplification. Also, it was noted that the S-frame format itself has some interest outside RTP. So, for instance, you could use web transport or RTC data channel with web codecs and still use S-frame in between to do end-to-end encryption. So that means that we want integration with RTP, but we also want S-frame to be used outside of RTP. In addition to that, on the WFC side, so the API level, the WebRTC working group adopted the WebRTC encoded transform as a first public working draft, and the functionality already shipped in Chrome since maybe a year. And it's also enabled by default in Safari Tag Preview, and it might be also in the queue for other browsers as well. So progress is being made to add support to allow web pages to use S-frame or to implement end-to-end encryption into browsers. So the WebRTC encoded transform is definitely used for end-to-end encryption. It's also being used either for prototype or real applications for other stuff like app-specific metadata enrichment of encoded payloads. It was also used for emulating RED if it's not available in the browser. So we are seeing that solutions in browsers are more and more using that. And we're seeing that existing WebRTC solutions are using like Google Duo, FaceTime, WebEx. They're all adding progressively support for end-to-end encryption. And they're all doing that with different S-frame-like formats and flavors. So there's no interoperability. It's not the same kind of technology. It's very related, but it's not exactly the same. Some workarounds are being used. So it's not great. And it's not great because it's a security privacy technology. And usually having just one well-identified piece of technology to do that is better. So next slide. Based on that, my understanding is really that we need to make progress. I think we already had a similar slide 1 year ago about that, saying, hey, things are starting to evolve and end-to-end encryption is being shipped and we need to make progress. And it's even more the case now. And it's particularly the case for S-frame within WebRTC ecosystem. For Web Transport or Data Channel, we still have some time. But for WebRTC ecosystem, it's really getting fast there. So that means S-frame RTP integration and S-frame SDP integration. My understanding in the past was that IETF112, for instance, would be responsible for doing the S-frame RTP integration, but we are seeing email threads on the S-frame working mailing list about that. So first question I have to the AVTCORE working group, no, previous slide. My first question would be to be clear about where should that work go, or where should it be worked on? Should it be all done in S-frame working group, the S-frame integration, or would it be better to do that in AVTCORE? Because currently I see that there are discussions being done in parallel, and maybe it would be good to be clear exactly about where is going the work and which working group is responsible for which part. Any opinion?
I think that probably certainly anything where like RTP architecture is implicated is best in AVTCORE, because I feel like that's where the expertise is.
Okay, so that seems reasonable. For SDP integration, I guess that it should be S-frame or MMusic, correct?
Probably, yeah. Though certainly, insofar as it's, especially because it probably needs something more complicated than just what a payload format would do. So probably that needs MMusic integration.
Okay. So it's good. We're in AVTCORE.
Okay.
Colin?
Yeah, just on that point, the SDP, obviously MMusic is the home for SDP, but the payload formats are usually defined in AVTCORE, and that specifies a lot of the SDP parameters, so it maybe needs review here as well.
Okay. So it's great. We're in AVTCORE, we're discussing that, so let's try to make progress. So at last meeting, we discussed a lot the packet versus frame issue. And I think that there are common requirements in both cases. So if we put the packet versus frame issue aside, we can try to focus on common requirements. And that's what we try to do in the next few slides. So yeah, the S-frame working group, there was good discussions in the S-frame working group mailing list about various approaches. And basically, I think we know that middleware middleware being like SFUs, network intermediaries, or browsers, cannot inspect encrypted or transformed packet payloads. But they still, especially SFUs, they still need information to route encrypted transform packets separately. And that's especially the case in SVC simulcast cases, but it's already the case, for instance, in non-simulcast cases. So one question was from the mailing list, whether it should be, if possible, just from RTP packet inspection to determine that content is encrypted or transformed. And if so, where should the information be located? Should it be just a payload type? Should it be a dedicated RTP head extension? Should we put that information in RTP payload? So that's feedback I like to get from AVTCORE folks.
Colin?
Hi, I'm a little confused about what you mean by this question, because my understanding is that the payload type defines what is within the RTP payload. So I'm not sure what you mean by the separate points there.
So currently in the current and deployed environments, the payload type is defining the codec. So let's say H264, VPI, VP9. And we need at some point this information anyway. And that's how it's being deployed. But we could also say that, no, that's wrong, and the payload type should say, oh, it's encrypted content, or it's content that you do not need to care. It's opaque. And that's one possibility.
So I don't think that's what the payload type does in RTP. The payload type defines the payload format, and the payload format describes what codec it is and how it is packetized. And so if it specifies what's the contents of the RTP payload.
Yeah, I mean, the only thing is that it was, I mean, it was raised in some discussion on the main list that maybe just signaling that in the SDP that the content was, even if it is just, and we don't change the packet decision of the codec, just encrypting the payload, the payload of the RTP packet, that it could go from within the same payload type. But for example, I think that it will have a different payload type to specify that it is not the normal payload type. So this is it is not we are saying what is the solution is that some people have claimed that it could be done in a different way. So just we were seeking guidance about exactly if this could be an option, or we should just if we should, for example, say sending an RTP packet with the payload type negotiated for VP8, then the payload must be VP8, and LSV or whatever can inspect it and expect to have the correct payload in there.
So I think that there's sort of separate issues here. I mean, one is how you signal it, and one is what is the payload format. But the question on the slide about is this located in the payload type or within the RTP payload? I mean, that they're the same thing. So are you asking about the way that the data is encoded into the packet, or the way the data is, or the way the contents of the packet are signaled?
So yeah, I was trying to cover the fact that in the S-frame working mailing list, there was a proposal, and usually you could say, oh, I want to negotiate VP8 because that's really what I want, and I want also to use S-frame. So then you need to provide that information, the fact that you're using VP8 and the fact that you're using S-frame to the other party. And this information, VP8 plus S-frame, could go also in the RTP packet, or it could be left elsewhere, and so on. and that's what I would like to hear about. Because we think that getting both information, the fact that yeah, it's VP8, and yeah, it's encrypted, it's transformed, would be useful by looking at RTP packets.
Yeah, I mean, I think my argument here would be if you're changing what is the payload, then that's a different payload format, and maybe that's some sort of encapsulation payload format. But it seems strange to say this is VP8, but the content isn't actually VP8.
Yeah, sounds good.
Bernard?
I think what there's a couple of distinct issues, as Colin said. One is the negotiation of specific RTP header extensions, like we've had the frame marking header extension, there's the dependency descriptor. You know, there's routing information that's being negotiated. That really does not tell you anything about what's in the payload, although people have been using it as a kind of a hint of what might be in the payload. Like it's likely to be encrypted, but it doesn't really tell you that explicitly. And the thing is that you could negotiate those RTP header extensions without encrypting the payload, right? So, and then there's the payload type, which is and negotiation of things like the codec. But again, that currently doesn't tell you whether the payload itself is encrypted. So it seems to me like there's something missing in there. And I know there's been discussions on the S-frame mailing list about whether you really want to even tell the SFU that you're encrypting it, or it's none of the SFU's business. So I know there's that issue, because really the encrypted payload is really an end-to-end thing, and SDP really isn't about that. It's hop by hop. But I think it's a little bit dangerous to assume that because you've negotiated a particular header extension that everything will work end-to-end with an encrypted payload. Because there could be, as we just talked about with the B2B UAs, right? There could be somebody in the middle who's looking at this, and if the SDP doesn't tell it that to give it any inkling that it's encrypted, it probably could become a problem at some point. So I think there is a missing piece that's maybe some of the information I think is in none of the things you described, or it's not payload type, it's not a header extension. It's probably something else in SDP.
Yes, I mean, it seems to me like conceptually what this actually should be. I mean, insofar as everything in the RTP session will be S-frame, which I think is what people probably want, because I think having this be mixed is a security and nightmare. I think what this actually is a profile, much like SAVP is a profile. This is a new transformation like SAVP, which I mean, I don't know if you necessarily, I mean, whether you actually negotiate it that way for backward compatibility reasons is a separate issue. But I feel like that might be, at least conceptually, the cleanest way to approach it. And if we have to hack something to get it to work with browsers or whatever, so be it. But I know that certainly, especially for the problem with having it being a payload type is the payload type multiplication issues, and also just I don't know if you want to be able to negotiate both, S-frame and non-S-frame in the same session, because that sounds like it's a good way to accidentally discover you're not end-to-end encrypted, or not discover it, or worse. Suhas?
Thanks, Jonathan. I think there's a tight situation here between the signaling layer and the RTP layer here, even the SFU to make some decisions. They're not two different islands. They have to be combined together in any business logic that you apply on per packet basis. And SDP is the one that sets up some kind of stream level indications. And speaking here, just in terms of the RTP layer, it's a bit kind of not thinking about what happens in the setting up there. And I did see some of the discussions that are happening on the S-frame mailing list about saying for a media stream level or for a particular payload type applicability, that if this is an S frame or an S packet, that way for it's kind of hint to the, and STP offer answer can be defined explicitly to say what the behavior should be. Saying it's a hint to the SF utility. It's saying that you don't look into the packet further because it's end-to-end encrypted. You don't get anything. Versus something like if it is not an end-to-end encrypted thing, you can look into the packet to see, for example, the audio level or something like that. And hence having some, we need to kind of look into the picture of the signaling and the media to make a decision. Just looking at the RTP there would kind of leave a bigger the system setup that's happening here, and we need to consider that as well.
Mo?
Yeah, I think conceptually, I agree with Jonathan. That the first thing I thought conceptually was also profile level things like that, SAVP or something like that. If I was an originalist, I would say that would be the right precedent and model to use. However, I'm not an originalist, and I don't believe that things decided long ago should impact everything today. And I think I would argue that SAVP has caused a lot more damage than good. And there's been a lot of problems with things like SDF for security and things like that. I would caution against trying to do what logically makes sense precedent-wise is to make a new profile out of this. But I think that's probably a mistake that rehashes a lot of the mistakes that those older profiles caused. What makes more logical sense to me is this is just an encapsulation, like RED or FEC or anything else. It's an encapsulation of some other payload. So I think it makes more logical sense to declare all the real payloads and then also declare the encapsulated types. And then what you actually send on the wire is the encapsulated type. So it would be a different payload type number. And it would just be an encapsulation of some other payload type that is also in the STP, but won't appear on the wire because you're not actually sending that format on the wire. That's what I think makes more logical sense.
Colin?
Yeah, I think I agree with what Mo just said, that this to me does not make sense as a profile. I think it's entirely the wrong level of modifications to be represented as a profile. It strikes me as a wrapper format, much more like you read or the retransmission formats also. And I think what you are specifying here is a wrapper format, which says that the content is, for example, VP8 but encrypted. And so I do think, so I don't think this is a codec agnostic payload format. I think this is a codec specific format which wraps something which wraps a particular set of content. So what you're signaling is that it's this wrapper format, and what is being wrapped is this. The existing payload format gets put into the wrapper, perhaps with an additional header added before the front of it, and is signaled as a payload type, wrapping some existing payload type.
Yeah. Okay. I think.
Yeah. So I just one response. I mean, I think that's probably a fine solution. I think the SDP part's going to have to be a little tricky, because if you want to say I'm willing to receive wrapped VP8, I do not want to receive unwrapped VP8. But I think that might be more an MMusic consideration than a AVTCore consideration per se.
Yeah, I think it's a good issue to tackle as well, and to keep track of.
Yeah, I mean, I agree there's probably some signaling issues. I suspect they're not that different to the ones we use for some of the retransmission or redundancy formats. I guess we'll need to work that through.
Okay, sounds good.
Okay, we don't have a lot of time, but maybe this is my, we could say it's my last slide. No, go above. Previous slide. Yeah, so I think from what I hear is consensus that we need an ability to identify whether it's encrypted and transformed, and also the underlying codec type. I'm less sure about whether it's good, whether there's consensus on having a solution that is independent of the exact transform S-frame format. It seems to me that it would be good to have, because what we're seeing, it's being deployed, there are various S-frame or transform being used. And so the wrapper format will only be able to, we don't want to have a wrapper format for each and exact transform S-frame transform. And yeah, the scope is really related to WebRTC audio video codecs only. So there's a limited known set of codecs that we want to support, and it's not a fully generic solution in any way. The target is only WebRTC audio video codecs. Yes, you're on view.
Question here. Going back to your the first slide of having different systems implementing S-frame versus S-packet in different different phase, like Google, FaceTime versus WebEx and those kind of things. I'm going back to if you go with an alternative payload format or some kind of wrapping payload format, how would that level of interoperability be achieved between the two different implementation of the S-frame or versus S-packet? So are we kind of saying that we have to do one versus the other, or are we saying we don't talk about that and somehow the implementations need to figure it out?
It's an open question. I don't think that there's consensus on on anything there yet. What is known now is that it's either a packet level or a frame level. We're not interested in more complex cases. But other than that, it seems there are implementation supporting packet and implementation supporting frame level. So in terms of spec, maybe we'll support both, and then we'll see from there. Or maybe we can get some consensus on picking just one. I think so for me.
Okay. Colin?
Hi, so I realize we're out of time, but so I saw Justin's comment in the chat about we want to apply S-frame packetization rather than VP8 packetization, and this perhaps comes to the heart of what's the issue here. My understanding was that what you wanted to do was take VP8 content, in the same way it's usually packetized, encrypt it, and then put it into a new payload format. Which seems to be the model I was talking about, and I thought Mo was talking about. But if Justin's talking about doing something different, then perhaps we need to have a conversation to make sure we're all understanding the same thing about what's meant here. It would seem you packetize the things you would put. Packetize it for VP8 as if you were going to put it in the packet, encrypt it, and then put it in the packet as S-frame with VP8 inside. But if that's not what's being proposed, then I think we've got a bigger discussion to have.
Yeah, I'm sorry this discussion got cut a little short by other things running over time. I feel like this needs more discussion. We should try to figure out what's the best place to have this discussion. Would people be able, we tried to do an interim on this before, didn't really have the right take up, but if we can get the right people in a room, an interim or perhaps a more informal side meeting might be helpful, just so we can sort of get convergence on, make sure everybody's talking about the same things architecturally. Is there any interest in that? Quickly, hopefully. Justin says yes. Colin says yes. Okay, we'll try to, SUS says yes. Okay, we'll try to plan something out on the list for that. All right, that seems reasonable.
Okay,
Go ahead.
I think we've reached the end of the meeting, and we want
Okay.
to thank everyone for coming.
Okay, the only other thing I wanted to raise is that Spencer mentioned earlier on the RTP over quick discussions. We think probably having specifically RTP over quick discussions on the AUT list would be best, whereas more general media over quick on the mock list. So just to keep things somewhat separate there, that's probably the best organization for that. And with that, thank you all for coming, and we will see you at other sessions here or next time, possibly in person. And we'll arrange for interim on the SRAM issues. Hopefully we can get some convergence on that. We'll discuss that on the list. Thank you, everybody.